We're going to knock out 3 members of the Enterobacteriaceae family all in one video. This is a little more ambitious than normal, but I think we've grouped them nicely, so it shouldn't be too bad. The 3 we're going to cover are Enterobacter, Serratia, and Klebsiella, or as we at Sketchy Micro know them as, Pterodactyl, Triceratops, and finally this Ankylosaurus with a club tail, or kleb tail, will be Klebsiella. We're going to set this scene in a hospital room of a patient, so let's get that drawn. Alright, now we'll give this guy an oxygen mask, and this will represent that he has pneumonia. And down here we're going to have this bag of urine hanging off the bottom of his bed, and this is to show you that he has a urinary tract infection. And as you've probably guessed, pneumonia and UTIs are the 2 most common illnesses caused by these bacteria. And the reason we chose the hospital is because all of these are really important nosocomial infections, or hospital-acquired infections. And a big reason why it's important to know that it's a hospital-acquired infection is because that means that you want to think, there may be some multi-drug resistance here. And in this case, all 3 of the bacteria we're mentioning have multi-drug resistance, and you'll probably want to remember that. And we'll make sure to do that by drawing a bunch of pills on the ground next to the patient to remind you that patients in hospitals are taking a lot of antibiotics, so a lot of the bacteria that you find in hospitals are multi-drug resistant, and that goes for these 3 especially. And when you get a question on how to treat an infection by one of these guys, you'll want to think along the lines of a carbapenem, where resistance typically isn't seen. So far we have that they're all multi-drug resistant, and that they're all nosocomial infections, and they most often cause pneumonia and UTIs. And there's really only one more important shared feature that we have to cover, and that's that they all ferment lactose. This characteristic is often one of the first mentioned in questions to help differentiate between the various Enterobacteriaceae. The only other important lactose fermenter you'll have to remember is E. coli, which we're going to cover in another video. So right away, if you see that a culture can ferment lactose, these could be part of your differential. So to remember this, we're going to draw a milk carton because, of course, milk has lactose. So when you see it, you should think lactose fermenters. And also take note that we're drawing the milk carton pink. Why is this important? Well, lactose fermenters form pink colonies on MacConkey agar. So it's kind of a 2-for-1. The milk represents lactose, and the pink color for the pink colonies on MacConkey agar. And I really can't hype this aspect enough. You have to remember that these are lactose fermenters. If a question stem gives you that an isolate was taken and grown on MacConkey agar and formed pink colonies, I mean, that's a huge help. That really narrows it down to these and E. coli, so you have to be able to recognize that. And of course, after I've really stressed that, there is a caveat, but it is really pretty low yield, so feel free to plug your ears and hum for the next 5 seconds. I won't be offended, but I do need to mention it for completeness' sake. So Serratia does ferment lactose, but it does so really slowly, so sometimes it can actually show up negative on a lactose fermentation test. So don't necessarily rule it out if the organism isn't a lactose fermenter, but luckily there are easier ways to tell it's Serratia on culture, and we'll discuss that in a bit. Again, everything we've added so far applies to all 3 species of bacteria, so maybe pause the video here, rewind, and make sure you're comfortable with all of these features before we start drawing them out individually. Okay, well let's add our prehistoric friends one at a time, starting with the lower yield ones, and eventually we'll work our way over to the high yield Klebsiella. Let's start with Enterobacter. Enterobacter was actually the major inspiration for the whole dinosaur theme because it just sounded so much like pterodactyl. So let's draw Enterobacter, or Pterodactyl, flying over the patient. A quick disclaimer here, if in real life your patient starts to complain about seeing little dinosaurs flying above them, you might want to consider turning down the ketamine drip. Anyway, Pterodactyl is flying, so it's very clearly motile. Only Serratia and Enterobacter display motility within this sketch, and you'll see that later after we've finished all 3 of them. And really, there aren't many more defining features for Enterobacter, so that's great for us. Now let's get to Serratia, which is actually my favorite of the 3. Serratia will be represented by a Triceratops, or as we called it earlier, Triceratops. And we're drawing him as if he were kind of in motion, charging with his right arm up. This is to remind you that he too is motile. Remember, of the 3, only Klebsiella will be immotile. So let me tell you why Serratia is my favorite. It produces a red pigment when cultured, and you've probably actually seen this pigment and just didn't realize it. If you're like me and when studying for the boards, you may neglect some of your daily chores, especially in the bathroom, and you get that pink ring around your shower. Well, that pink pigment is actually from Serratia, and that's the same pigment you see when it's cultured. So you can think about that the next time you shower, or you can remember that Triceratops is bright red, so that should remind you of the red pigment that Serratia produces. Alright, so if you had a really awesome childhood, then you probably went through a dinosaur phase like I did. In fact, if you were a boy and you didn't want to be a paleontologist, I'm willing to bet you probably didn't have many friends. But on the other hand, if you really liked dinosaurs and actually became a paleontologist, you probably still didn't really have many friends. I'm just kidding. I know we have a massive paleontology following, so I don't want to offend any of you. Anyway, if you know dinosaurs, then you've probably heard of the Ankylosaurus. You might also remember they have that club-shaped tail, and that club will remind us of Klebsiella. And actually, our club tail will have these 3 spikes that have A's in them. And these are 3 A's to remind you of the 3 A's of Klebsiella, which is alcoholics, abscesses, and aspiration. That means that they commonly infect alcoholics, they commonly create abscesses, and they commonly get started from aspiration. And the Ankylosaurus also has these really thick shell-like scales on its back, and this is perfect for us because Klebsiella actually has a capsule, so we'll cover the spiky scales on his back with this mucus substance to remind you of polysaccharide capsules. So how can you tell that Klebsiella is the cause of a patient's pneumonia? Well, a common clinical feature that becomes kind of a buzzword for many students is that these patients cough up a currant jelly sputum. The boards don't generally go for such obvious buzzwords, but you may see it in your class exam, so we'll include it. So we'll draw Klebsiella knocking over a jar full of currant jelly. That should be a pretty obvious reminder. Additionally, the jar has spilled its contents all over Klebsiella, and it's sticking him to the table, almost like a tar pit. And this demonstrates that Klebsiella is the only one of the 3 that's immotile, especially in contrast to the other 2 which are clearly active and definitely demonstrating motility. And a little subsketch we'll include just for fun is this chest x-ray. And you'll notice, if you look closely, you see this cavitary lesion on the patient's right lobe. Well, that's to remind you that Klebsiella, forms abscesses, but also that if you looked at this chest x-ray, you might originally think it was TB. So in a question stem, you might get something where, they originally thought it was TB or something that really makes you think it is TB, but you have to keep Klebsiella in mind. And lastly, you should know that Klebsiella is urease positive. So to represent this, we'll use our bottle of ammonia and have the patient spraying Klebsiella specifically. So you know it's just Klebsiella that's urease positive. And that wraps up 3 bacteria in 1 video. I hope you enjoyed it.